Hello everyone, so welcome back to a YouTube channel, and today's question is odd even linked list. So we are given head and we have to group all the nodes with odd indices together followed by the nodes with even indices and return the reordered list. So the given example, it's 1 2 3 4 5, and we have to return 1 3 5, after that 2 and 4. Yeah, and we have to solve this problem in O1 and own complexity. Okay, so let's just move to the intuition part first. So let's just skip that O1 space complexity constraint and understand the question first. So we are given this linked list and we have to reorder this in this form: 1, then 5, then 4. After that we have to do 7, then 9, and then 10. Okay, so it should be the form. So what we can do, basically, for first approach we need basically these values. Okay, so we can create one array or list, anything, and we can take one variable and like temp and set it to head, and like go to its first place, add it in this array. After that skip this position and go to this and add 5. After that similarly go to 4 and add 4 here, and we'll check if we will move to here, and we will check if temp is null, so we will just go out. Again we will start from next position like 7. We'll add 7 to the end. Similarly we will move one step forward, 9, so we'll add 9. After that we will move to 10, add 10, and after that we will move to here and it's not here, so we will just get out of the loop. So with the help of this we find all the values. After that we will move to each node separately. Let's just create another one. Okay, so like 1 7 5 9 4 and 10. And what we can do, basically, take this value, replace it by this, take this value, replace it by this, so it will become 5. Okay, similarly 4, so it will be replaced by 4. So okay, and similarly we will go forward. So on 7 we will replace it by 7, and after that we will go to 9 and next here, so we will replace it by 9. After that we will go to 10 and replace it by 10. Yeah, so after that the modified list will be 1 5 4 7 9 10. Okay, so odd position ones are together and even ones are together. So yeah, this is the approach we can use, and we can use one array. So let's just move to like some pseudo coding part. So the pseudo coding will be, first what we have to do, we will initialize temp to head and take an array, or we can use vector in C++. Okay, and we will iterate till temp is not equals to null, and temp next is not equals to null. And after that we will just, what we'll do, first we will do add it to array dot add or vector dot pushback. Okay, so temp value, and move our temp to next position, basically skipping one. So with this we will add our odd indexes once. Similarly we will initialize again temp to head next and do our part again similar to the first one, not equals to null, and temp next not equals to null, and we will add it to array and move one step, skipping one. So yeah, so with this approach, we will add all the values in our array. And now what we'll do, we will initialize temp to head again, and we will take a variable 0 for the array indexes, and we will move till the last node. Okay, while temp is not equals to null. Okay, what we'll do, we will set temp val equals to array of ith index. Okay, so we will move the index and we will move the temp equals to temp next. Okay, so yeah, this is the pseudocode, and the time complexity in this will be, so this will take big of n by 2, since we are moving only on the half of the positions, because in this we are going through this for 1, okay, 1 4 and 9, and this is the half of the length of the linked list, since it is 6 and we are only moving on the 3 of the nodes. Similarly, for this part, it will be big of n by 2 only, as we are just moving on the even indexes nodes, and this will be big of n only, since we are moving on the whole linked list. Okay, so the whole time complexity will be big of n by 2 plus big of n by 2 plus big of n, which is roughly approximately 2n, or we can say n also, and space complexity will be big of n, since we are using an extra array. Okay, so yeah, so but since now what we have to do, as we have seen in the question, there's a constraint of doing it a open space, so we will now move to that approach. So let's just take the linked list again. Okay, any other example? So it will be 1 3 8 5 4 6. Okay, and now what we can do, will, if we can do it in a open space, what we can think of, what if we just modify the connections in this linked list, so that if we will return it doing it in place changes, we can do that. So if this next becomes this, and this next becomes this, so we can have 1 then 8 then 4. Okay, and similarly, if we can have this 3's next to 5 and 5 next to 6, and we can have 3 to 5, 5 to 6, we can have both 1 1 8 and 4, 3 5 and 6. Okay, and if we can connect both of them, then we can have our whole linked list 1 8 4 3 5 6, our result. So we have to think of that solution. So what we can do, basically we can take two variables. First one is like odd, this is the odd pointer, and take an even and have even at this position. Okay, and what we'll do, since we both have these two, so we can set connect, break this link, connect this to this 8 1 to 8. So odd next, odd next will point to even next, or odd next to next, anything will work. Okay, now it will do similarly for even. Even next now becomes even next to next. Okay, this one. Now what we just have to do, we will move odd to here and our even to here. Now we will do same thing, and once we like connect all these nodes, we can have one connected to 8 to 4. Similarly, 3 will be connected to 5 and 5 to 6. Now we can have two linked lists which are in this part, and we have to just connect 4 to 3. So what we have to do, since once we reaches the end, even will be at 6th, okay, and odd will be at 4. Okay, now what we have, like we have to connect this 4 to this 3. So we have to somehow keep this 3 first at the first part in some another variable. So let's just take it like in some even head, let's just say, okay, and have it in the first place. If we have even head here, so what we can do, we can add these connection saying that odd next now points to even head. Now this is connected and we can return this odd head, and it will return the linked list. So I think yeah, this solution will work. So let's just have a pseudocode for this. Okay, so what we can have an odd in list node initialized to head and even load to basically head next, okay, and one another even head to even basically. Okay, now what we can do, while we will check for the condition later. Okay, what we have to do, we have to modify the links. Odd next will become odd next to next. Okay, similarly even next now becomes even next to next. Okay, now we just have to update our odds. Odd equals to odd next, move odd one step ahead, and even also even next. Okay, now I think this will work, and after once this while loop is completed, we'll just update the odd next to even head. Okay, and we can just return the head of the linked list. This will connect both of the linked list. So I think yeah, this will work. And now what we have to check, this condition what we have to put. So let's just check what we have to put it here. So as you can see, like odd is here and even is here. So even is always one step ahead of odd. So if we have this odd length linked list, whenever we reaches the end, so even will be here and odd will be here. So I think we cannot move odd here because odd will become null, and we cannot move even here. So we can have a check if even's next is null. Okay, so if even next is null, odd can also be not moved and even can also be not moved. So yeah, one of the condition will be even next if even next is not null. Okay, even next not equals to null. Okay, and another condition, what if the length of the linked list is odd? Let's just say we have one other node like 2 here, so we can reach odd here, but if we move even to here, even next to next, so what it will become, even it becomes null and we cannot move ahead. So if even becomes null, we have to stop it here only. So we can have a check also if even becomes null. So yeah, this will work. Whenever even becomes null or evens next will become null, we can come out of the loop stating that we have moved till the end. And so the space time complexity in this case will be, this is doing it in big of n by 2. Okay, since we are just moving on the half of the nodes of the linked list, like on this and this and this and this, so only half of the nodes are reached. Okay, but we are modifying this two steps, two modifications are being done. So we can say like it is big of n by 2 star 2. So roughly estimate big of n we can say, and space complexity will be big of 1, since we are just using 3 pointers, basically odd, even head and are even. So yeah, I think this will work fine. Yeah, let's just move to the coding part. Okay, so what we can do, basically take two nodes, odd to head, similarly even to head next. Okay, now what we have to do, we have to also take another node, even head, even head to even. Just we need to remember the even head, basically you can say same. Now we will just move on our loop stating if, whenever, while even is not equals to null, and even next is not equals to null. So now what we have to do, we have to modify our connections. So odds next will become odd next to next. Okay, is it right? Similarly for even, next will become even next to next. Now we have modified the connection, we have to move both the pointers ahead. So odd will become odd next. Similarly, even will become even next. Now, whenever we come out of this loop, we just have to modify our connection between the last node of first and the first node of even. So it's just that this thing. Now we can just return the head of our linked list, as we have done the in place connection modification. So we can return this head only. So now what we can see, if this is null, it will just basically come out of this loop before the modification, and odd next, basically head next, will move, will be updating to null. Yeah, it will work fine. We do not need any basic like check here, so we can just run our code. Yeah, it is working fine. We can test on all the example test cases. It is working fine. Let's just try to submit it. So yeah, it is failing if we have an empty linked list. So if empty, this is empty. Similarly, we cannot have this check. So we have to like add some base test case. If head is equals to null. Or we can also have a check if head next. No, I think, yeah, we can have a check, but it will work fine. We just have to return the head only, because null will return null and head next, basically it will return the head. So I think this will work fine. Yeah, it is working fine. Yeah, so thanks everyone for watching. In case you do like this video, please do subscribe our channel, and we'll post more solutions and questions accordingly.